Zoom. So welcome everyone to our series of webinar from Fluke Networks. As usual, we have opted for support you in your business, in your work through some additional technical discussions, product technologies, and information to share with you during those pandemic days where we cannot possibly meet in person. And we have wanted to expand our knowledge to you as well as far as we can during those weeks. And thank you very much for this continuous attendance for many of you guys. We have seen people in our webinars in the numbers of hundreds of people, so that's great to see you guys, and always welcome to see more of you and in our more webinars to come. In our session today, we will be talking about the best practices for testing fiber optic cabling. So it's one of the topics that we've been asked to go into some details, which due to the time of 1 hour of a webinar, it's a bit tight to talk heavily deeply, but we will be trying to scratch some surfaces around it and make sure that you guys enjoy this session and enjoy the topics that we will go through them. So a bit of Fluke Networks. Fluke Networks has been in the industry of testing and measurement for many years, and we have a load of expertise in our team to serve you and serve the customers with related to fiber and copper optic, fiber optics and copper testing in the field. So we have a number of hundreds of years of expertise. We have the biggest, I would probably say we are the biggest a library of knowledge base of and articles that tackle technologies and technical details on how to do testing and how to understand the testing of copper and fiber. We have multiple services centers around the world as well. We have something that was stuck in my mind, that we have almost 25 tests every second. If you do that in an hour, in a day, in a year, we're almost looking at 2 plus million test results a month. 2 million test results, and you look at the year, we're almost looking at three quarter of a million of test results. So that's a lot. So I was talking 2 million a day, not 2 million a month, sorry. But yeah, that means we are serving you guys and helping you guys to do as quickly as possible test results in the field. And we have been always present in the standard bodies, so we are able to cover you and support you when it comes to latest standard updates. One thing I wanted to highlight here as well, that we have a team of support engineers in our technical assistance center spread across the world, from the Asia Pacific to the US. So we have round the clock teams to support you in your questions and problems. Always reach out to support. They will be here to support you and help you with any questions you have. As an agenda today, we're going to talk a little bit about safety. You know, fiber optics is not always something that we need to miss or forget the safety aspect of it. We're going to talk slightly about the cleaning and inspection. We had a few weeks back a session dedicated on fiber cleaning and inspection. If you have not attended that, please reach out to us. My colleagues Salah and Werner will be able to help you sending the link of that webinar so you can attend. And then we're going to talk about the Tier-1 testing. What does it mean, Tier-1 testing, which is the loss testing, and what's Tier-2 testing, which is the Otdr testing. Before I continue furthermore, I didn't state in the beginning that my colleagues Salah and Werner are joining me as co-hosts in this session to help you answer and attend the questions that we have. And if there's anything we can help, we will be directly answering you. We will have more people joining us from the Technical Assistance Center as well. And if you have any questions during the course of the presentation, please go to the question and answer Q&A tab in the Zoom and ask your questions, and we'll be more than happy to answer you straight in to you. So looking at fiber is one of those biggest mistakes that anybody could tell, and it's been always the nightmare. Fiber has been the question of safety with so many installers and so many technicians and engineers in the world. So why is that? Because fiber is being launched on a wavelength that we cannot see. It's called an infrared. And when we talk about infrared, it's not visible to the eye, but it is very harmful to the eye. And that's why we see the infrared in a non-visible wavelength. That means we cannot see, and what we cannot see could cause harm without even us knowing. That's why you see a lot of warnings on the fiber cabling systems or on the fiber equipment to not look into the cable, or not to look into your SFP and look if there's a light coming out, because eventually you're not seeing the light, but you will probably damage your eyes. So as a consideration, they consider always that the fiber is live and act upon it. Don't look straight in the fiber, don't look into it, stay away from it. Don't approach a patch panel with open ports. Make sure that they are all covered with dust caps. And whenever you need to do any work on the fiber, just go and use an electronic inspector with a camera and a screen that you can see what's going on, rather than using the optical camera, which can increase the damage of your eyes. So dirt has been always around us. For some of us, dirt is fun to play. For those kids, yeah, they will always love to play with dirt and mud and stuff, but it's for fun, yes, but not for fiber, because dirt is a very big cause of a bad connection or bad links in our fiber. Why of that? Because statistically, 85% of the fiber failures are coming from contamination. So, you know, the fiber coming down from multi-mode 50 micron to the single mode 9 micron, we're talking about very tiny little piece of area that we send the light in. And our hair is 75 microns, so it's even smaller than our hair. That means we cannot see, and we will not be able to see what's going on here. For that, we need some specific tools to help us observe what's going on in our connector. And this is a case of a connector that has been damaged because of a mating from a dirty connector that has some contamination on it, and the contamination caused a permanent damage on that connector. That's why this kind of observation needs to be done. We need to clear our connector before we start testing or connect that connector to an active equipment. And if I cannot clean the connector, don't try anything more, replace. If it is a patch code, throw it away, replace. Don't use damaged connectors to connect to your network, because you can cause more harm than you could do for yourself. So again, equipment repair will be there. Watch it out. So let's take another scenario, which we discussed before many times, and we always talk about it. Dirt is contagious. So imagine I'm having a very lovely connector in my patch panel, beautiful, clean. Now, I bought a patch code that I didn't know that it was dirty, and I connected that connector in the patch code to the clean connector in the patch panel. And the result would be that the connector I have in the patch panel now is contaminated and will cause me some failures or some drops in my connection, or added values or added losses in my links. That is dangerous. So keep an eye on that as well. So what we always recommend, the rule of thumb, the 3 rules for fiber: inspect before you do anything in fiber, inspect. Clean if necessary, then inspect again. Make sure if I am clean now, if my connectors are clean, that means I can move on. I can start connecting the tester to my cabling, or connecting the active equipment to my cabling system, because that would be my peace of mind. And we've seen a best practice that some of the data center owners, or some in the dense telecom rooms, in order to avoid missing cleaning fiber cabling, they are putting Velcro to the click cleaners in the cabinets, so that they can attach them, so technicians in the field will not forget that and will not say, oops, I forgot to bring with me the cleaning kit. No, don't need to worry about it. It's there in the rack. If that is over, if that is finished, open the second rack, get it from the second rack, get it from the third. There's no excuse not to clean your fiber cabling system before you do anything else. So for that brings me in the first poll for you guys to help me and help you also with some information to share across us. So hosts, if you don't mind to start the first poll, please. So the first poll is talking about which fiber testing method do you use in your project? Is it a fiber inspection only? Do you use power loss, optical loss test sets? Do you use OTDR? Do you use a mix and match between OTDR and optical loss test sets? And something that we wanted to ask, like, yeah, my installation is good. I trust my installation, so I don't need to test. And that could be also another behavior. We've seen it in some areas in the business. So we wanted to make sure that we see the alignment together around it and see how you believe in doing it and how you're doing it in your field as well. So I think we can share the results of the poll, if you don't mind, gentlemen. So majority of the people, I would say 50% of the people have believed in or are doing a combination of OTDR and optical loss test sets, which is good. So at least you do that mixing of both components. Some people are using OTDR and some others are using the power loss, which is also the purpose of this discussion today, to look at what are the components and why we use that and why we use not that. So thank you for that. We can close the poll. So looking at fiber. So we are looking at fiber from a technical definition from the TIA, defining what is tier 1 and what is tier 2 in the fiber testing. So the TIA have defined a tier 1 testing, which they call it a required parameter, and we cover that in our CertiFiber Pro as an OLTS platform. So it's often referred as OLTS. It's using a power source and a power meter. So we start with one side of the link and we inject the light and we measure the loss of the light and the total loss at the end of the link. And for that one, we can support up to 12 kilometers in multi-mode and up to 130 kilometers in single mode. Now, in tier 2 testing, which is a recommendation by the TIA, it often talk about OTDR, which is the optical time domain reflectometer. And for the OTDR, it's good and helpful to help us look at the length of the fiber and identify the different components of our fiber, from splice, could be the connector, could be a bend or a break on the cable. And mostly the OTDR is being used from one direction. So I use it from the beginning of the link and I shoot my test across. So you don't need two directions, two equipments on two directions, on two sides of the link. But we need also, you will see it later on, that we need to move the OTDR to our other side. So we need to test OTDR in two sides, and we have defined what we call a smart loop system. And OTDR measurement can go for multi-mode up to 40 kilometers and in single mode up to 130 kilometers. So let's explore a little bit about what do we mean about tier 1 testing. So tier 1 testing is actually what we see today in every discussion, that applications are becoming more and more demanding on the bandwidth in our links. So the slow application, the fast application of yesterday became slow today, and the slow of today will become, this fast of today will become slow for tomorrow. All that have a major impact on what we do on our fiber links and how is our link capable to carry this application. So the same application you see here, the 100 gigabit, depending on the application, depending on the platform, it becomes even tighter and tighter. If you hear from the guys of Cisco, they talk about 40 gigabit in 1.5 dB loss. And that's a pretty tight loss on your link, and there's no joke about it. You need to make sure that your cabling system is perfect. So tight budget means that we need to know how many connectors I'm putting on my links, what is their performance, and how is my workmanship, and how clean is my system before I connect any applications to it. And we look at it like, is fiber easy to understand like copper? The question is actually no, because copper has been a lot easier to define cabling standard with the applications and mixing and matching the applications to the category of cabling. So there has been always a match between the application and the cabling standards. Unlike the fiber has been scattered between the cabling standards and what we call the application standard. And what we call that, this mismatch is causing a lot of distraction in the market, where which one do I use now? Do I use the application standard or do I use the cabling standard? And for some people, they say, you know what, I'm gonna use somewhere in between those two. I'm gonna work out on those middlemen in the middle, and I call it a custom limit, where I define what I need to work, what is best for my business, and define that best for the business in my testing limits. So that's why we see now a new trend in the custom limits, and we've seen some vendors also in the market, some cable manufacturers, calling to test according to a custom limit, not according to cabling limit or application standards, because that's how probably the future is going to take us there. So the three types of limits that we observe in the market today are the international standards, where they are TIA or ISO limits. We see they are working on the number of connectors and the fiber length, while the IEEE, which is an application standard, focuses more on what do I need to run the application? How many dB do I need to run my application? And when it comes to the last one as a custom limit, like what we said in the previous slide, it's a mix and match between both components. So we need to define what we need to do to make that system work in between the cabling standard and the application standard. So a little bit of brief about the development of the TIA, where these things were defined in 2018. For some of the people, they know it. Some of them, they probably might not be following those updates. But the idea here is to show you that TIA over the years has started to tighten up the limits of the components that they wanted to test. So they tighten up the loss per dB per kilometer from 3.5 to 3 dB. The mating of the first and the last connectors from 0.75 dB to 0.5 dB. So that means there is changes in the standards, but is that enough? Probably not. And that's why we always ask you and ask the technicians and the project managers in the field, please make sure before you start testing in the field, make sure that your equipment is upgraded to the latest firmware, because the latest firmware always carries the latest updates of the standard. So if there's any changes between the previous firmware and the current firmware, and you are not aware of that, you might shoot some results which might not be as actual to the current standard revision or version. So please make sure that you follow that in the right way. So let's take an example of a link. How do we compare that link of a 500 meter between a TIA limit and an IEEE limit? So in that 500 meter, the IEEE tells me to run 100 gigabit base DR, I need 3 dB. While if I look at this budget of this link, I'm having 500 meter link into 1 dB as single mode is 0.5 dB. I'm having two connectors. I need 0.75 per connector. That means I need 1.5 dB. So the total loss budget that I have as calculated budget is 2 dB. Now let's look at what would be the result of the tester that we induced in that cabling. And we got a result of 2.6 dB. Now, what would be the question here? Will it pass in TIA? Certainly no, because TIA said my budget is 2 dB, my link is 2.6 dB. I cannot pass this link. I receive a fail. But for the IEEE, like, yeah, that link works. I'm fine with it. I can deal with it. The application, the 100 gigabit will work perfectly on the cable. Now, which one to take? And that's where the dilemma of the cabling in fiber optics, which one to choose. And that's the awareness of the links that we're testing versus the application that we're going on. We need to have a harmony in between those details. And that's why the need for custom limits. If I do the same, if I add more connectors on the link, and the total link remains 500 meter, but I added multiple connectors, let's say a patching between the patch panels and the racks in the data center, connector to connector to connector to connector, and then what happens next? Yeah, I'm probably on 10 gigabit, things were working good. But if I move now to the budget of what I need for the 100 gigabit, I'm having 500 meters, again 0.5 dB, but now I have 6 connected to account for in my budget calculation. I will need 5 dB as a total calculated budget, while still the IEEE requires 3 dB. Now, my tester tells me I get a 4 dB loss. What does that mean? Does it mean a pass on TIA? Yes, it means a pass in TIA. I'm below the budget. That means TIA tells me, good job, you can work according to TIA. But can this application work in IEEE? Then certainly no. For that reason, all those components and all this pressure and stress on the links have taken hard discussions in multiple areas, and particularly in multi-mode. Because most of the current installations in data centers and in enterprises are in multi-mode. So tightening the application limits means that we need to tighten up also the techniques of measurement. Hence, the launch in 2010 for the insert flux measurement, where we needed to have a technique to tighten up the belt, let's say, on the measurement of the multi-mode cabling, and to make sure that the variation of the results, if we don't use a source which is insert flux compliant and a code, a test reference code that is insert flux compliant, we will lose potential accuracy in our measurement. And we have a variance in our testing that could go up to 60%. So you could get a failing pass or a passing fail, and this could lead to a disaster. So we needed to have a system that gets the right measurement on our fiber cabling in loss tests. And what's the reason behind it? If you look at the historical side of the measurement of the fiber cabling, we used to use more of an overfilled launch condition. So we overfill the core with LED, and then we shoot into the core and we shoot into the cable. And that leads that the light can enter not only inside the core, but enter also in the cladding. And that could allow some lights to jump from cladding to core and some misalignment. And at the end, it leads to inaccurate results. So the idea of having insert flux is to focus the light and make it right inside the core of the 50 micron, because nowadays we don't use any more 62.5, we're using 50 micron, and we need to really go into the core of the 50 micron. Are we getting the right transmission? Are we getting the light getting right inside that 50 core? And we should not go into a small sources like the VXL testing, because we don't only look at the total core, we look at the part of the core, which makes also our measurement accuracy goes wrong. So we need the insert flux condition to work perfectly. Again, application limits becoming tighter and tighter. So we need to get accurate testing to get things right. So when we look at it, even we look at a lot of applications coming up today, high-speed applications, moving more from multiple fibers to run an applications to a two-core applications, like the wideband multi-mode fiber. So we're looking at 40 gigabit in two-core. That means we need to make sure that our cabling is capable of handling that. And hence the requirement for probably OM4, OM5 to run those applications because of the model bandwidth that it can deal with. So we need to make sure that our testers can test accurate stuff, and as well as the cabling that is being installed can handle this. Any piece of wrong connection, bad dirt, bad splice would lead to that application not working on our fiber networks. So let's go to that a little bit exercise, which I like to set up a discussion around it in the next coming slides. But let's see, if I have a pet at home, if I have a dog, if I have a cat, if I have anything at home, if I need to measure that thing, would you think that the dog, if you tell him, come to the scale and stand on the scale to measure your weight, would you think the dog or the cat will listen to you? Definitely no. It would be like, they will look like, no, what are you talking about? What is my, I need to play, I need to do something else. So the best way to do it is to actually start with what we call it a reference. So you stand on a scale by yourself, you reference yourself, then you know your weight, then you carry the pet with you, and then you look at the weight and you see the new measurement of the scale, and the actual weight of that pet that you have would be the negation between your total weight with the pet minus your weight, so you get your lovely pet weight. So let's look at this table. So if I measure the dog, I am getting the total weight of my dog to be, let's say, 36K. My cat would be 3K, but if I try to play with the canary here, and I get the canary and I stand on the way on the scale and I see my weight going 1 kilo down, and like, huh? I'm supposed to be at least stay with my weight or a little bit more, but why do I go down? What's going on? What could have gone wrong here? And this is why we see something very similar to that into our fiber cabling system, because normally if I have a very high loss, I know my cabling is not working. But if my loss is very small and the deviation is small, I'm at the very thin line of having an application to pass or fail. And it's even in a 1 dB range. So what to do now? So how do I deal with it? And that's the purpose of my next poll question. Jens, if you don't mind, to help me with the next poll question. So the next poll question is, how often do you set a reference in fiber optic measurement? So we've seen people in the field carrying loss measurements, light source power meter or optical loss test sets, and we ask them, how often do you do that? And we get different responses, and I wanted to also have that conversation with you, ladies and gentlemen, to understand the importance of the reference. Because as we tighten up our limits, doing things right becomes even more important than ever before. So as we speak, the responses are coming in. And I repeat, if anybody has any questions during this presentation, please use the Q&A tab to have our colleagues answering you. We have Jim Davis also from our headquarters joining us. He's our marketing engineer behind lots of videos and documentation that you see on the website. So welcome, Jim, as well. It's too early for you on the Everett side, I think, but welcome on board. And I think we're good with the poll now, gents. So can we share it, please? So we see some responses that comes with that I need to do my poll. I need to do my referencing at every start of the project. That means that counted for 44%. Some people said I do it with every test, which is also a big number that we will explain that part. Multiple times a day, which is okay, not bad. And once a day also depends on what you do. Once a week, or I don't need to set a reference, my tester is good. So going back to our topic, why do we need a reference? Remember the story of the dog and the story of the weight. Setting the reference is pretty much essential. We need to set things right in our cabling system. So the standard requires and guide and put us into a guidance. It's not because Fluke want to do it or X or Y or Z. It's actually the standard. The standard becomes more strict about what is needed to be done. And what do we need to do in setting our or preparing our testing for fiber optics, and particularly in optical loss measurement. So if I do read the two codes, and that's why this slide is purely focusing on two lines, the standard requirement. You need to use what we call a one jumper method or one code method, and we need to use test reference code. And the test reference code are the, by definition, not the standard patch code that you bring out of your installs in your site and you open the box. Oh yeah, I have 300, 500 fiber patch code. I will pick up 2 and we'll start testing with those 2. They are not enabled and they are not made for that purpose. They are made for application to run. They are made for the system to run. But for testing, you need particular and special grade of connectors on those codes and the quality of that codes to be to a certain level that you don't compensate or you don't take the results in a different direction. For that reason, again, I'm not going to go into deep details because that will be a topic for our in-depth fiber half-day session that we will do in the next couple of weeks. But the purpose here is to share with you that the standard has defined that the cords needs to be perfectly made, and the loss of the multi-mode, the connector loss of the multi-mode is 0.1 dB or less, and on the single mode is 0.2 dB or less. And that's the mating calculation that needs to be done when we mate a test reference cord connector with a normal connector in your patch panel. That could be the mating of those two has been defined to be better than 0.3 dB on a multi-mode and better than 0.5 dB on a single mode link. So test reference cords are mandated and are needed to be done. So if we look at what we used to see back in the days when we use a normal cord, when I need to do a calculation, I used to add per connection, per adapter, 0.75 dB. So in this link, I have two adapters and a link of a cable that is 3.5 dB and 0.75 at each connector. To calculate my loss is simply adding those two connectors here and maybe 100 meters, 1 kilometer, whatever the length, into 3.5 dB per kilometer, and I get my loss budget before I start testing. So that for many, that's used to be calculated by hand, or the tester will do it to you. So back in the old standard, the mating of the connectors was 0.75 standard. But according to the new limits, the standards has changed those matings. So the matings has started with the latest references to be between the first connector and the last connector is 0.5 dB. Remember my discussion on the TIA updates back in 2018, 3 dB per kilometer. So that's how we do the calculation again. 0.5 plus 0.5 plus the length of that cable into 3 dB per kilometer, I calculate my loss budget. Now, what if I have more connectors on the link? What do I do and how do I calculate my length? So I do look at my connector, the first connector and the last. Again, according to TIA, is 0.5 dB plus the calculation of how many connectors, I get the loss budget. Now, if I have the right things done in the reference, I can assure that that the measurement of that link that I will do at the end will be correct and not something that will overshoot. So for that reason, referencing the tester is very important. And what we saw from some of you guys, setting the reference multiple times a day is needed. Yes, because I need to make sure that my tester and my remote, my source and my meter are in synchronization. They understand each other. They know what is the power injected by this source and measured here. So they set the zero, as we said in the measurement, so they know from where I should start, and when anything comes on top of that, anything I add is actually the loss. And that's why people who are doing this kind of reference, adding one jumper or one adapter or two adapters, you're not getting yourself a help. You're putting a 2-cord method or a 3-jumper method, which leads us to have a different results than what we intended to do. There are specific cases where you need to have 2-cord method or 3-cord method, but those are very specific. On a day-to-day enterprise cabling, we will need to have a 1-jumper method, and that's why you see our lovely Caesar saying, yes, that's the way we need it, and that's the way we need it, and we need to work on it in the field. So please look at the reference as a first and key objective in that one. Now, the question comes, how often do I need to set the reference? Some of you have said multiple times during the day. I will come to it, but some of you have said at the start of each project. If I start up a project and my project lasts multiple days, meaning I will set the reference today and I keep the reference for the next coming couple of days using the same reference. I'm disconnecting my tester, removing the cords, adding the cords, removing the cords, adding the cords, and coming tomorrow, after tomorrow, after tomorrow. And I'm still using my same reference that I did 3-4 days back. Is that the correct way? Certainly no. Because when we set the reference on the mating of the source here with the cord, with the test reference cord. And that cord, when the moment we remove that one from the tester, means that I need to do another reference, even if it is by mistake. I need to re-reference it again because the mating here condition has changed at the source. At the meter, it's fine, but at the source is something that we should not allow to happen. So that's why the correct methodology of doing a referencing is to do it probably at least once a day or multiple times a day if I am going to keep my tester away from testing for a couple of hours. And I'm probably need to disconnect my tester. So how to set the reference? Usually the technique that we coach our engineers and technicians in the field, you need to do that kind of connection, connect the red to the red side of the patch code or the test reference codes to our source, and then connect the black one to the meter on the other end, and similarly the red on the test reference code on the other side to the meter on the main machine. So to tell, our machine has 2 sources and 2 meters. That's why we can test 2 cores at the same time. And hence we are having a reference for 2 cores at the same time now. So we start the reference, we save the results, and now we disconnect, we get another code, the complementing code of the test reference code, and now I need to check, are these codes good or not? I need to connect them together and start testing those reference codes. Are they good? Can I trust using them to test my link? Will the mating or the test of those codes will be in an acceptable zone to get my results correct at the field? And these are the areas and the limits that the standards have defined. And pretty much defined, the results will come in front of you of the tester and boom, done. Now, if I ask the question, do you remember what I was talking about in the past couple of slides? I think no. Because we always tend to forget some of the areas where, what do I do now? I put the reference, do I do it the right way? Did I put the right direction of the code or no? What do I do? I forgot what the guys from Fluke told me. I forgot what I learned from my CCTT. And then you need to go and call and lose time. So, and sometimes people don't do that. They go on and they continue. So for that reason, we always ask, do you expect everyone to remember everything about it? Certainly no. But don't worry, with Fluke Networks, we get you covered. We support you and we help you because we have the wizard available at every time you want it on the tester. It's there on the main screen of the tester, and the wizard takes you step by step. What do you need to do? Which color of the test reference code you connect? Where do you want to connect? How do you connect? All the way up to the testing the reference codes and making sure that they are also good. For that reason, we do that for you and we store those results as a TRC to you in our results. And when you download them into Linkware PC or upload them into Linkware Live, you will be able to see those things that I've done my TRCs, what is the length and what is the date that has been done and what is the limit. It's a TRC limit. Now, if I look at the following lines, I see that I see some of those test results done and they are within the same day, which is good. Let me see. Oh, it's 1:13 p.m. What time was the reference? 10:52 a.m. Looks like I'm in a good shape because my reference, considering and hoping that nobody had removed the code from the source. And I can look at those results that they are genuine results following that the reference was done correctly. On every also test that we have, we can jump and see what is inside. I see that I'm using a 1 jumper method here. I can see that what is the length of the reference code. And if I have any negative number on my test reference codes, that means my codes are becoming waste and not helping me at all. I need to throw them away and I need to replace them as soon as possible. So the wizard is your key. The wizard is there. And we're proud to say that we are the only company who can do that and help you with setting up the right reference without losing time, without doing test results, doing tests and failing things that you don't want to fail in the field. Now, going into the second part, the second tier, tier 2 of OTDR. So OTDR has been for some time in the old days used by the telco operators and for the very long haul cabling, and it's been there for many years. But we've seen the introduction of OTDR into the enterprise market because there was a need for it, and because of also it was the application speed limit become an obsession for some, and we need to get and make sure that we measure all the components of my link to the best I can, okay, so that I eliminate any possible risks in my link. So if I have a dirty connector or a bad connector, I need to identify it, I need to fix it. If I have a bad splice, I need to fix that as well. So what does the OTDR do in short? So it sends a light, a pulse out of the source. It checks the reflected light that comes into the OTDR port. So it is a bidirectional port, so it can send the light and sense the lights again. And the further the light goes, the more I know about the length. So it's about time and the distance of the light. The further the light goes, also, I can check the fiber loss. And when light hits a connection, I can get a different type of light that the OTDR will detect. Oh, there's a connector here, there's a splice here, there is a break here. And all of those details will be represented. Now, the representation is something that we will discuss also in the next coming slides. So the OTDR technologies focus on the ray light scattering, which is mainly the loss, and the Fresnel reflection, which looks at the connectors and if there's any breaks in the cable. So in short, for people who are used to see OTDR results, that's the common screen that we get on an OTDR. We see the backscatter, which is the drop of the light from the start of the link all the way till the end. And we measure the loss across the total cable. Now, when we look at those spikes, what are they? Those spikes, for us, we call them reflectance. And reflectance is usually a way or an air gap that happens in the fiber cable that we are running. So if I have any bulb of air or any airspace in the cable, could be from a splice, a bad splice, could be from a connector, I will have air coming in between those connections or those fiber links, and then light will come back and tells the OTDR that there's things I cannot see much. It's similar to what we see here in this picture. We see the restaurant, but what I see on that restaurant is not only a clear view of the person inside, but I also see the building. I see a car here. I see some details which are not good. To eliminate those details, I need to probably come closer, meaning eliminate the air gaps between the objectives. So that's why we have those reflective events happening when we have most of the time a connector, and it's the beginning of the connector, we see it and we analyze it and we understand that these are potential connectors. And how do I measure the loss of that connection or the reflectance? Is the negation of the loss that is in the beginning of the reflectance, and at the end of the reflectance, I measure the loss and I know the connector loss. So this is what we call reflective events. And when it comes to non-reflective events, which is happening from a splice or could be from an APC connector or angle polish connector, because they are meant to be manufactured with an excellent reflectance. So they show me a drop rather than a spike in my link. I think enough technical questions, and ready for a third poll. Jens, if you launch the third poll for our audience, please. So how do you test with an OTDR? Testing with OTDR has some techniques, and some people know it, some people don't know it, and some people just do it because somebody told them to do it that way. And when I look at it from one perspective is that, do you use patch code with it? Do you use a long cable, or we call it a drum or a launch cable at the beginning only? Or do you use a launch cable in the beginning and another drum at the end of the cable? There are different techniques of the testing, and let's hear from you guys, and we will share with you the actual standard guidelines on what do we need to do in those kind of things. So as we get more results, I think we have a bit of a balance between the result of the three types. I think there's one leading, which is the correct one. I will not talk about it until we get the click of the minute. Yeah, so we can stop if you don't mind. As we see, the guidance when we talk about it, it's about, can I use 3 meter or 5 meter code? We will see that in the next slide. Why not? We don't recommend that, and we don't like it. And not us, it's the OTDR don't like it. As the technology cannot digest small links. Do I need a drum at the beginning of the cable? Yes. Do I need to have a drum at the end of the cable? Yes. Can I deal with it without drum at the end of the cable? No. Wait for it. You will see it in the next coming slides. So if I have a launch cable with a patch cord, what do we see here? The light comes out from the OTDR. So the time for the OTDR to start stabilizing the light becomes too short to see the first connector. And the idea here that we see from what we get on our event map, which is the specialty of Fluke Networks, that we make life easy for you to see it. It's not only graphs and graphs and graphs and spending hours to understand them. We tell you there's something really strange here. I see a hidden connection after 2 meters of my OTDR. And then I see a link of 51 meters. So for me, this kind of link is not showing me good thing, because first thing, I cannot see the first connector of my link. Second, I cannot see the end connector of my link, and I cannot know the overall loss of my link. So multiple mistakes are happening here because of using only patch code at the beginning and nothing at the end. So what do we do here? So what do? We need, officially by the standard, to have a cable, a drum. We call it drum, you call it launch cable, a length of cable that you start the link with, attaching it to the OTDR and attaching it to the first connector of the link. That's where the gray area here. And the second drum, or the second tail, comes at the end of the link, where you can see the second one. The intention of those launch and tail is to allow us to visualize the loss and the first connector. So we see the spike or the reflectance of the first connector, so we can measure the loss of that connector here. And at the last connector, I could see another reflectance, and I know the loss of the last connector. All that comes in the benefit of the link. So we need to make sure that we get this right. If I don't have a launch and a tail cable, I'm going really wrong. And for that reason, you know, as we said before in the loss, the TRCs, the test reference codes, there's a lifetime for those connections. And to prolong the lifespan of the connector of the OTDR, we need to use what we call the sacrificial code that we enter one time here in the OTDR, and you could use that for 1,750 connections and use it, and then you prolong the life of the OTDR port. So why do we need also another discussion? Why do I need a bidirectional test? Because sometimes if I go in the fiber from one direction, I see some data. If I look at a splice here, the splice could give me, if it is good, it gives me the right result, which is the right loss. But sometimes I might get a wrong data here. I might get a false loss or a false fail or false gain. So what do I do here? How do I know that my connection is good? For that reason, the standards also recommends and ask people not to use only one direction of the OTDR. So you need to have a launch and tail at the beginning of the end, that's for sure. But don't test only in one direction. You need to test in the other direction. For that reason, we need to understand the mismatch in the backscatter from each direction to know if that link here showing me a loss or a fail with 0.8 dB and a pass with minus 0.37 dB. Which one is correct here? The correct is actually when I do the averaging of those two measurements, and then I come with the correct result of the loss of each and every component of my link. For that reason, the standards require and ask us to go that direction. So what do we see on the OTDR? We see multiple things on the OTDR. I will go through it very quickly. We see them from a good connector to a bad connector, a good splice to a bad splice, launch condition, hidden event, band, splitters, end of fiber, all those to visualize and help you see things in the right way. Well, let's see another example here quickly. I have this link which shows me a reflectance here, a reflection which goes into 0.14 dB, and then a certain reasonable acceptable reflectance. But let's look at the second pulse here, which shows me a lot bigger than the first one. What are we having here? I'm seeing here a high loss and a bad reflectance, which leads to me that there's something really wrong at this connector that I need now to go and fix that connector because of both the loss and the bad reflectance. So the event map help us look at things not only in traces, because when we look at the traces sometimes could be difficult to decipher unless we have really good experience into it. But with our OptiFiber Pro OTDR, we can take that information instead of deciphering this into an easy way to look at it and tell you that it's a band. That is a band in the cable. And the technical requirement here is like, you see these 3 wavelengths showing me different information. From experience, I will know that when I see those kind of variation in multiple wavelengths, that means a question mark, am I having a heavy band here? So that's an example of how to rescue yourself with an easy visual interface rather than deciphering hours of understanding what could that mean. That leads me to the last poll. That will be a quick one because it will help us close the last part of this presentation, because we wanted to know how many of you are using bidirectional OTDR. How many of you hear from the consultant or hear from the end user, or you as an organization believe that bidirectional OTDR is required? So do you do it? Some people will say never, I've never done it. Some people, I know, I don't know when to use it, or I've been requested to do it, or I do it on every project. I know for a fact large big projects in our region with large international consultants, they do ask for bidirectional OTDR testing. So as we fill in this information, so bidirectional testing, I wanted to share with you quickly what we do in the field. So I think we should be getting ready to have the answers. So I think majority of the people in the audience here have answered yes. We can end the polling, please. So I answered on every project they do bidirectional testing, which is a big thumbs up. Well done. I think that is a very correct answer. When requested to do it, well, sometimes people want to go quite quick. They do one side, but remember the standard asks for bidirectional testing. It's not a choice that you have to do, or Fluke asked for it, or a brand A or B or C did ask for it. It is a must to be done. It's a standard requirement. So what do we do here? If I'm doing bidirectional test, what is to be done? More details will come in our next month in-depth overview on the fiber, but I wanted to share with you quickly how people do it. So if I have a bidirectional testing, the non-standard way, because you will see why, I'll start my first test. I will get my direction of that link of 300 meters. I test from here to here. Yeah, perfect condition. The launch is here, the tail is here, and the first test is okay. Now the standard tells you, because of, remember, the mating between the connectors of the launch cable, we should not play with that mating. That means I need to take that OTDR now, after the first test, to the other end, put it at the other end, and start testing backward. And then when I do that, I need to move the OTDR to the other side. So it's like running a quick marathon between the two sides. And if you have a long distance, that would be a disaster. So what people usually do, they follow this procedure. They test the first link and they test all those links, and then they move to the other side and they test. So let's follow this practice here. So they are literally not following what the standard requires to actually measure. You need the first and last connection. You need to take the OTDR to the second end. They start going one link after the other, one link after the other in one end. And once this is done, they take the OTDR to the other end and we start testing again from that other end. Is this correct? According to standards? No. Do all of us know about it? I would say majority no, but that's the reason why we're coming here to tell you, watch out. There are some practices that we think we're doing it right, but they are not really right. For that side, Fluke Networks have introduced the specialty smart loop, which is our trademark and our invention in the OTDR, to do a bidirectional test without moving the OTDR away from the telecom room that we are in. So it is easy to configure it on the OTDR. You just select Smart Loop OTDR, and you will, let's say you have a link that you have your OTDR, you have your lunch, and you have a link. And at the end of the link, normally you put a tail fiber. But what we ask you now, to connect the tail from one core to the second core in your link, because in enterprise we use normally duplex cabling. So connect the second point of the launch cable to the second core and add an additional drum of cable at the end of fiber B. So we have fiber A and fiber B. This is very helpful in many areas. And imagine you have to test a cable that ends up in an antenna or ends up into a very delicate environment, or let's say in an oil rig. Are you going to fly the OTDR to the oil rig and come back and go and come back? So we're trying to help in finding an easier way. And that means that what we're doing now, we start our test in fiber from one direction. So I shoot my light inside the fiber A. It goes in the fiber A, goes into the drum, and goes back to fiber B and goes out from here. So I test one direction of that cable. That means I move now the OTDR to the second cable. As you see, I'm still in the telecom room. I did not change anything in that side, in the side of the middle drum. And I shoot the light from fiber B. So it goes from the other side of fiber B to the drum and goes back again to fiber A. That means on each and every fiber, I've done the two-direction measurement. So the good thing is that the OTDR will automatically do the calculation and will help you split the results and get you the bidirectional average on your screen without even moving out of your OTDR. So how does that work? So the OTDR will take that result that comes in and start slicing it into two fibers. So fiber A, fiber B. So that's from one direction. And then start taking that fiber into a more graphical user interface on the event map. And we see now that my fiber is 165, 167 feet. And that's the loss. And that's, you can see here, 3 tabs, 1, 2, and average. I can look at my fiber. If I click on it, I can see different directions. So that's my results of the first fiber, fiber A, and my results on fiber B. And with save button, all is saved. With 2 tests, remember, I've done 2 clicks on 2 tests. I've got 6 results, 2 directions for each core and 1 average. So how is that happening? If I have the result, I see direction 1 at this side. I see direction 2 at this side over the same cable, which I have already tested. And it's end up with the directional, with the average bidirectional average. So you see here, the connector is the same as this connector, is the same as this connector. So whichever direction I'm having, I will be able to see my link. And that happens in 2 clicks on the cable. And all what you need extra is 1 extra drum, and that's it. No extra payment, no extra membership to subscribe to, no extra license, no extra anything. Just 1 extra drum and you're set to go. So for that reason, I would set my takeaway for this session. Remember the beginning, and it's always been the pain, inspect your connector. Please inspect your connector. Don't rely that the connectors are clean. You might have come last month and yeah, I cleaned my cables last month, but yeah, last month till today is the 30 days. We don't know what has happened. Clean if necessary. Repeat to clean. Inspect and clean until you get a clean connector. Tier-1 loss testing gets you the, tells you if the light goes out at the end of the tunnel and tells you how much that light to allow you to see if that application will work. And don't forget that test reference code are important. You need to set the reference with a test reference code. And don't forget that it is a 1 jumper method that needs to be done. Tier-2 OTDR troubleshooting is great to find the end of the fiber, great to find bends, breaks, any problems on my cable, find the loss of components of my link. Maybe that connector is not good. Let me fix that. I can get a better loss overall. So I can do my troubleshooting on the OTDR and then come back to Tier-1 and retest after I fix. and then I get things right. So keep doing things right, please. So again, from another terminology, how ISO look at it, we saw about tier 1, tier 2, how ISO look at it. Again, light source power meter, OLTS, optical loss test sets with one jumper method, with TRCs, OTDR with launch and tail. And don't forget, we can do the smart loop. And I wanted to kind of wrap up my slides with the Fiber for All promo. We've been running this Fiber for All over the past couple of months, and it's important to realize that this promo is reaching to an end soon. We have done a lot of activity around it. Our prices have been slashed and reduced heavily for this promo. If you have any requirement or any need for any fiber tester or a kit with fiber, please reach out to us. We are here to help you, to support you in this product. Time is running out soon, so we hope to help you more with those before that time ends up. And thank you for your attendance. I think I jumped 2 minutes above my time, so I'm sorry, gents. But if you have any questions, please keep on throwing some questions. I have not seen how many questions is happening in the background. And mic's off, mic's unmuted for Salah, Werner, and Jim. If you need to ask any questions, please. So, let's.
Yeah, thanks. Well, yeah, I think most of the questions were answered. Having Jim Davis with us, yeah, it helped a lot. But yeah,
We've been very lucky today. Thanks, James, for your early comment. I really appreciate it.
No, thank you. That was a very good presentation. I enjoyed it, and it was factually very accurate.
Very good. Thanks for the one who wrote it. By the way, the one who wrote that presentation is Jim. So thanks for you, James, as well.
Yeah, thank you.
So if we're not having any more questions, if we're not having any critical point that probably Jim want to close with it during this slide or during this session, please, if you have any closing statement, Jim.
There is still one question, or it was asked already similar. So if a consultant asks for the reflective events on the end connector, but you have only one launch cord, is it then okay to test from both ends, but only one direction? So they're asking, is it correct or not? So since they only have one launch cord, still the consultant asks for the reflective events on the end connector. Maybe.
So it's a matter that, Jim, go ahead.
Sure. If you made a good point about needing to use a launch and a tail or a receive fiber to be able to measure those connectors. Now, you also did a good job of showing the importance of bidirectional averaging. That's just the mechanics of the OTDR as we go from one fiber type to another. We need to measure the loss in both directions to get an accurate value. So if you only have a launch fiber, you're not going to measure the loss of the last connection. And if you take that launch fiber to the far end and you test it the other way, you'll only have one direction of loss for that last connector. So you won't be able to make an accurate measurement of the loss in both directions for those two connectors. To do that, you need to use both a launch and a tail or a receive fiber or receive drum.
Yeah, that's a valid point. Yeah. So that's why we need to make sure that to get a second drum or the end cable or an end drum or tail, it's not the investment. It's not a big investment. It's not about the investment. It's about the accuracy of the results that we have and to get things right. I think we've stressed a lot into it, and we keep on talking about it till the standard says different. But we're following strictly the standard, and standard have showed this is the right way, and measurement tells exactly the same.
Another question, and maybe it's a repetition. You can pull that slide with the overview. So someone asked to tie a fiber optic cable between two passive racks, only 250 meters from each other. Is the light source power meter enough for certification, or you need also OTDR?
This is one of those questions where we like to say, it depends on the contract and what the end user is asking. If you are in a data center and your intention is to transmit 400 gigabit Ethernet, you may have an interest in knowing the reflectance of those connectors, which would require an OTDR test. But if you are just required to do the loss testing, a light source and a power meter, as Wael mentioned several times, is the tier 1 or the basic requirement for loss testing.
Yeah. Great.
Someone asks or says the prices of our machines are pretty high. How can we get reasonable price? And I would like to answer myself. So while mentioned, we have a promo running. Nevertheless, we believe that by using our machines, you avoid mistakes. You maybe win faster projects or can make more profit by using our machine. So we believe it's like a cash machine. It doesn't cost you. It will make you a lot of money. Why you want to add something, Ursula?
Yeah, I want to add one thing also in the smart loop. Particular, some people talk, particularly they talk about our price of OTDR, but yeah, I said it's our price of OTDR is fixed. We don't add or charge excess for any feature that you want. For some other brands, if you need to say, I need that feature, you pay a few thousands of dollars for it to get that feature. For us, we don't need anything. And if you use smart loop correctly, you're kind of cutting down a lot of your testing time. So imagine how many hours and days you save if you have thousands of links of OTDR measurement. How much you save? You save days and days, if not weeks. So we have experience in some customers that they have cut down a single shift of a work because of the speed of smart loop. So I think in one of the slides, it cuts 1/8 of the time of the testing. So it's really fast. You only see it when you do it. And this is alone pays back in no time your investment.
Now, what will happen if an OTDR test is done without a launch cable?
Eventually, it's not correct. So if the consultant or the cable manufacturer, when they look at the results, they observe those results, they will immediately spot on those mistakes, and they most probably reject those results. So to do things right, listen to Jim.
Yeah, I was just going to say there is one situation where I'm less concerned about the launch fiber, and that is if my fiber is cut. If I'm on this call and this call drops and it's an issue with the fiber, I don't care about the first connector. I just want to know the distance to where somebody cut my fiber. But otherwise, you're absolutely right. We cannot see the first connector without a launch fiber. And a very common problem I see with the traces that customers send us is they don't use a receive fiber. And so we don't know what that last connector, what the condition is of that last connector.
Yeah, we have one question also. How long does the launch and tail fiber should be?
Well, the length of the launch and the tail fiber is a function of the pulse that you're going to be using. When we're configuring the OTDR, and our OTDR will configure itself automatically, it must choose a pulse width. It will choose a shorter pulse width for shorter lengths of fiber and a longer pulse width for longer lengths of fiber. So in the multi-mode world, where the longest piece of fiber is only 4 kilometers long, I wouldn't expect that you need more than a 100-meter launch fiber. Now, in the outside plant world, where we use single mode, and you may come across a large splitter, 16 or a 32 port splitter, or you may have a fiber that is more than 100 kilometers long. In that situation, you may use a longer pulse, and you want the entire pulse to fit into the launch fiber. Now, if you are using shorter single mode lengths, the 160 meter launch fiber that we include is going to work just fine up to a pulse width of 1,000 nanoseconds. And that is going to cover almost every common point-to-point link in a campus environment, in a data center environment. But when you start going to things like splitters on the fiber or longer lengths of fiber, then you may need to use a longer fiber. Again, it depends on the pulse width. And it is a rule of thumb that the physical length of the pulse is the length of the pulse width divided by 10. So if you have a 300 nanosecond pulse, it's about 30 meters long. If you have a 1,000 nanosecond pulse, it's about 100 meters long. So you would want to be using a launch fiber that's longer than your pulse. Sorry for the long answer.
Yeah. Great. So any closing word, James, to the audience before we wrap it up?
Oh boy, we're running over time, but hey,
yeah.
I'm really impressed to see so many people with such interest in fiber, and I'm glad that you were able to put on such a good presentation to help explain the ins and outs of working with fiber. Perfect. We know that we're just going to want more.
Yeah, indeed. That's always the question that we get. We need more in depth. So we're preparing the background. So for the people who are still there. Apart from the normal webinars that we're doing, we are preparing some deep in-depth. So you probably need to take a half a day with us on some time where we will talk deep down details into some copper or fiber. And that would be quite interesting topic, but requires, as I said, a longer time with us. Therefore, stay tuned for more information and more updates about our upcoming webinars and our specialty technical sessions. That will come in July. So stay tuned. Thanks everyone for attending. Thanks Salah, Werner, Jim. Again, big thanks for big kudos also for your attendance, for waking up so early in the States, and good luck for everyone in your return back to work. And hopefully you stay safe, stay good, and good luck in your business. Have a great day.
Thank you. Thanks for joining.
Thank you very much.
See you next week.